Hi everyone. In today's video, we'll deploy our application using Docker to our server that we have configured in the previous episode. So first thing we need to do, and we have our console here on the left-hand side, and we have an official Docker installation guide here on the right-hand side. So first thing we need to do, we will test our connection to our server. So once again, we execute the SSH command using the user that we have created in the previous episode, and we wait for a little while for it to connect. Okay, it has connected. So this means, and it didn't ask us for a password, this means that the keys that we have configured in the previous episode still work. Okay, then next thing we have to do, we have here on the right hand side, the step number 1, we need to say sudo. Let's copy this and let's just paste it here. Okay, it has connected. So next thing we have to do, we have it here on the right hand side, so we need to say sudo apt-get update, and then it asks us for the sudo password, and it just updates all our packages, and we will soon add the Docker package to it. Let's wait until it finishes. Okay, it's finished. Okay, next step, let's install some packages that we need. So you can see here that we already had all these packages, that's good. And now we add something called a GPG key. So this is just for the encryption. Okay, that's good. And now we just copy this part, and this will add Docker to our repositories. That's good. Then now what we need to do is we need to actually install it. So once again, we'll say sudo apt-get update. Wait for it to finish. And it's finished, okay. And now what we need to do is copy this command. So this is basically, as you can see, installing all the Docker parameters. And what I did not copy from it is the sudo at the beginning, and it has precisely asked us if we are the sudo or if we are the root user. Okay, let's say why, and let's for it to finish. Okay, so it's finished, and next step of our guide is let's look at here. So we have executed this, we have installed the Docker engine. Here you can install a specific version, but that's not what we want to do. We just installed the latest one. But in production environment, it would be actually a good idea to install a specific version. And then now great, we can just test if it works. So let's see, sudo docker run hello world. Okay, it's unable to find the image locally, therefore it will just pull one from the web, and you can see it works. If you get a message something like this, it means that it works. So here we have the hello from Docker, and that's good. This means our installation is successful. So now what we can do and what we have here is this Linux post install, because now if you notice, in order to run the docker run hello world, in other words, to create a docker hello world container, which does nothing else than just prints us the hello from Docker, if I try to run this, right, I get a permission error. It's like I don't have the permissions to do that. And actually, you might want to give your users the possibility to run Docker containers without actually having the sudo privileges, because you don't want all the users to be actually administrators. Therefore, it even provides you, if you read it carefully here, with the post installation steps for Linux. And the first point here is actually to manage Docker as a non-root user, and that's very good. Let's configure it. Okay, let's follow just this guide. So first off, sudo group add Docker. So this will add a sudo group, and we can see that it already exists. That's good. And that now we need to add our current user to it. So let's just copy it. So this little piece of script will add our current user to the Docker group, and that's good. So let's just, as it says, let's just log out. Let's just log in back again. Okay. And now let's test if we can run the previous command hello world without actually the sudo privileges, and it looks like we can. Okay, that's good. Okay, then we have a configuring Docker to start on boot. However, if you read closely here, it says that the Ubuntu it already does, so we can skip this part. We don't want to use a different storage engine. Okay, so our current Docker installation is finished. We'll need one more thing, so we'll just use Docker Compose. I think it's a really convenient tool to use, and it comes on top of Docker, so we also have to install that. Okay, so here we are on the install Docker Compose guide. Let's go down. Let's check the prerequisites very quickly. Okay, this looks good. Ask for the prerequisites. And then we have install compose. Here we select Linux. Okay, that's good. And here we have the command. Let's copy command. And asks us for a password. And then it did something. Let's see what we have next. We can apply the executable permissions to the library. That's good. And then we can install the command completion. This we don't need. And actually we can test if everything was installed successfully. And we can see that what version we are currently running. So that's good. This means that we have installed Docker and Docker Compose, and we can run Docker commands without using the sudo. So that's good. Now we can move to the deployment of our application, and we actually will need to create a Docker file and the Docker Compose file. Now what we need to do is we need to create a Docker file and then a Docker Compose file. And these are the configuration files that Docker will use to create images and then to start the containers based on the images that it will create. So in these files, we will essentially insert everything that needs to happen for our application to be deployed, or mostly everything. Okay. Let's get started. Let's get started from the Docker file. So the Docker file, the standard Docker file is what we would use to make the deployment if we did not have a Docker Compose. And then a Docker Compose is just a tool which allows you very easily to start or stop multiple Docker containers at once with one command. And in my opinion, it also takes some of the manual work out. So for example, you no longer have to remember very complicated run commands that, for example, map the ports or that set up volumes, but you can do everything inside a Docker Compose file, which then you can just commit to your version control system. So in our case, this will be Git, and you can version the file, and other people can also see what you do there. Okay, let's first start from the Docker file because this will be easier. Let's create a new file. It's just called the Docker file without an extension. And first thing we want to do, we want to know what base image our application will use. And then you can think about like base image, about this it's like a server, right, that your application will be run on. So it will be sort of like a server inside a server, although this is not entirely accurate explanation, but you can think about it like this. So we need the base image that we'll use. And this is usually very easy to find. You just have to open a browser. Let's make it here, go on the right hand side, and let's make our Docker, once again, let's make it go on the right hand side. Let's make it go on the right hand side, and let's here make the Visual Studio Code go on the left hand side, and let's Google for Docker images node. It'll take a sec. Okay, here we have the node official image. And here we can see basically the different versions that it supports. I think we were using node version, let's just check, node-v. We are using the version number 14. So let's grab the 14 Yeah, it makes sense. Let's for example use the 14 Alpine. You could go in here and check all the details. However, we are not using any advanced functions of Node, so that's not so important. We also could just do Node latest. This would give us the latest version. However, this is not very nice, and you usually don't want to do it because then you kind of lose control over your development. So it may be that there is an update to Node and you don't see it, and then you run it with the latest, and then it gets updated to the latest version and something stops working. You don't want to do it. You want to know what versions of what software you're using. Okay, so let's specify this. And by the way, if you have the extension, I believe, installed for Docker files in Visual Studio Code, you can automatically just alt-click this, and this will take you to the exact same page that we are visiting currently. As you can see, it took us to the exact same URL. Okay, so we will use this node image. Then what we need to do is we need to grab our files, because we need to install all our dependencies in the container. Okay, so let's grab the package log.json and package.json, and let's copy it to the home directory of the image. And then what we need to do is we need to run a command inside the container. And this will be npm install to install all our dependencies. And then we want to copy everything else. And the reason we do that this way is because of how these Docker creates these images, is because it's doing it step by step and then only saves the delta that changed. So if you run it for the first time, it will execute all the commands. But if you run it for the second time, it will recognize that, okay, I already have this command. This already has been run, and because of nothing changed here, I don't need to rerun it once again. And this is very powerful in Docker, because even though the first time you create this image, it will take a significant amount of time to install all the dependencies. However, the second time, if you don't add any dependencies, this will be very quick. And this is why you do that in 2 steps. So it's not the same to just copy everything at once, right? In 1 step, because we could copy everything and then run the install, but then with every change, we would have to reinstall all the dependencies, which is not what we want to do. Okay, and then we need a command that would be run, and that will be set as the entry process of our container. And what we want to do is we want to say npm, and then we want to say run, and then we want to say start. And this will essentially work the same way as if we said npm run start right here. But this ends with an error, and it's because what it's trying to do is, it even says it very clear, it's missing a script start, and the script start we can set here. And that we could, of course, there run it against nodes. So we could just say node and then app.js. However, I think it's common practice to do it like this, and I actually kind of like it like this. So just go to your package.json file, to the scripts, and then here you say just node app.js. And this should work. Now if we set here npm run start, it would start our application just fine. Okay, and this is actually it for our Docker file. It's super simple. Let's now move on to the Docker Compose file. So the Docker Compose will be a little bit more difficult, and let's create a file, however, not in the app folder, but in the main folder, so in the to-dos app folder. Let's here create a docker-compose.yml. So it's a YAML file. First off, we'll be using the version of Docker Compose 3. You actually need to do it so that it knows what syntax, what options we are using. And then let's define our services. And services are like containers. So these will be Docker containers. First off, we need Postgres service. This will be our database, because we will actually start the database also using Docker Compose. And now we'll see basically how easy this is to create to start a database using Docker Compose. And actually, if you use it on your local hosts, you can literally start a Postgres database using just 1 command. So this is very, 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 very nice. Okay, and now let's specify some options for the Postgres service. Let's specify an image. So it's exactly the same thing that we here did in the Docker file in this part. However, now, as we don't have a Docker file because we don't have a specific folder or specific Docker file for this service, which is called Postgres, we can just here specify an image that we want to use. Let's just use Postgres, then 14-Alpine. And this is just by accident the same version that we are using for the node. Now, what's nice, we can specify a rest-style behavior, and I like to specify a rest-style behavior always. And this is actually what will allow us to restart the application should something go wrong. We could also use or run our application using the nodemon because it has a similar functionality so that it will restart our application. However, but the choice is yours. Both options are viable. However, I think that if you scale things up a little bit, and if you will later on run many more containers, this is easier to monitor, right? So it's easier to monitor if your container restarts than something that a process inside your container. I think that's this way is just a little bit easier, and this is why also we don't run now the nodemon. We don't use nodemon to run our application because then we would have two things which would be restarting our application. This is a mess. This is not what we want to have. Okay, now very important. Now we need to specify some environment variables. And if we went to the Postgres image specifications here, there's one environment variable that we have to set, and this environment variable is Postgres password. Postgres_password. And what we want to do is we just want to tell our Docker that we want to create this environment variable inside the container, and we don't want to give the value of the variable here because we will commit this file to Git, and you don't want to have your secrets in Git. Right, so we will create on the server. We'll create .env file, and this will load the value of the macro variable from there, and it will send it to the container. However, there are a number of variables that you can use and that we will use. So we also have a Postgres user. We also have a Postgres DB. We also have Postgres port. We also have Postgres host. So basically, this is the database, this is the port, and this is the host of our database. Okay, now the next thing is we need a volume, and the volume is essentially a sharing of the file system between or folders in the file system between the container and our actual server. And this is very important because if we did not set that in the database for the database, which is Postgres, every time we recreate the container, we will lose our data from the database. And this is obviously not what we want to have. Therefore, we need to set a volume. So the data, even though the database will run in a container, it will have like a gateway to our server where it will save all the database files, and therefore the data can be sustained, right? So no matter how many times we build an image and then we start a container, we'll always have the same data there because it will not be saved in our container, but it will be saved on the server directly. So we can map a database folder. The folder doesn't exist, but it will be created automatically. So it will be created basically right here, right? So when we copy these files to our server, it will create a database. When we start it, the Docker compose, it will create for it a database folder. And then we map it, and this comes from the Postgres image. We map it to the following folder inside the container. This is where it stores all the database data. Then we need to do one more thing. We need to open the ports. In other words, to make the database accessible from the outside world. So if we wanted to run something like pgadmin software or any other that allows you to connect to the database, you have to do that. So in other words, then this port inside the container will be mapped to the port on your server. So then if you connect to your server IP address on this port, you will actually be connecting to the database. This is what you want to have. Okay, this is actually everything we need for our Postgres service. Now let's move on to the second service, which will be our app, and this actually will be our last service. Okay, let's see app, and then we want here we don't want to use an image, but we want to use a build, because this will be a custom build, and we'll build it using the Docker file that we've created before. So now we want to specify build, and then we want to have specify a context for this build, and the context for this build is inside our app folder, right? So it's inside this folder, because inside this folder it will look for this Docker file. And actually the name, so we just named the Docker file, and it will by default search for a Docker file. Then what we absolutely need to do is we need to also set up some ports mapping here, and because otherwise this will be not possible to access our application. So now we know that our application listens on port 3000, so we map the 3000 to the 3000 on our server. And actually this is not necessary that you map it to the same port. I just do it for convenience purposes. Okay, here we also want to specify that it should restart always, and this is basically what I also explained here. I think here I explained it having the application in mind, while it's actually, of course, here the restart attribute specifies the restartability of the database, but here we have the restartability of the application. And then we want to use an attribute depends on, which allows us to set a dependency. This means that the Postgres service will be started first, and only afterwards the app service will be started. Okay, and here we also want to set some environmental variables. Environment. And this is okay. Environment, and here, if you remember correctly, in the app file, we have the following variables that we would like to have in the container. So let's maybe copy them up here. Let's try to make some. Let's try to make it. Let's try to make it how we need it by doing the following. Okay, let's dash, let's splash, and let's move it a little bit back. Okay, so this will now currently get all of the variables, and this will forward them, or it will create them in the app container. So that's good. And I think that's our Docker configuration finalized. So we have now created the Docker files. We have changed we have added the start script. So now we can move on to our server. And first thing we need to do is we need to actually commit these files to the repository. So let's just write added Docker files. Let's sync the changes. And now we'll clone the repository on our server. So here we are on the left-hand side, we have our terminal. I have already connected to the server, and on the right-hand side, we have GitHub, where we are storing our code. So what we need to do now is we need to click on code, and we need to copy this URL, and we need to, in the home directory of our server, which is currently empty. So what we need to do is we need to say git clone and then paste the URL. And it will clone our repository, so all the files that we have committed to the repository to our server. And this is this easy. We can run ls command just to check if everything has been cloned. We can go inside the folder just to see if everything is really here. We can see that we have the app folder. Let's say ls-a, and we can see here that we have the app folder and the .git. However, what we currently can't see is we can't see our files, right? So we can't see our Docker files, and they should have been here. And this is because by default we are on the master branch, and we don't want to be on the master branch, but we actually want to be on the episode-7 branch, because this is the branch that I had active when I made the commit. So this is the branch I made the commits on. And now if you run ls.a, we see all the files that we have here. Of course, after you finish, this usually would be the case that you would merge everything to the master branch and run it from there. However, me, because I'm trying to store the code step by step or episode by episode, I will just using this episode 7 branch here. Okay, so what we need to do now is, if you remember, we have defined a number of environment variables. And in specific, we can look up here and we see them here. Okay, so what we need to do now is we need to define the values for these variables. So let's here in the main directory of our application create an .env file. So we do that just by saying nano.env. So now let's start with a Postgres password. And now for the password, I would suggest you use something a little bit more refined than I will. However, what is a good practice is usually to just generate a random or some random string. So maybe let's do that. You can do that very easily if we just go in here into our Visual Studio Code once again, and here we say node, and now we are able to run JavaScript code here, and we say require something called crypto, and we say dash random bytes, and then let's say 20, so we'll have 40 characters. Let's do string, and then let's set it to hexadecimal. And here we have a string. Let's copy this and let's use it as our password. Now, what else do we have? We have a Postgres user. So for now, let's set it to Postgres. We have a Postgres DB. Let's also set it to the default value Postgres. We could leave this out, but I just wanted to show you how you can easily change that. And let's then say Postgres port, and the Postgres host will also be Postgres. So Postgres host is equal to Postgres, and then let's say also, because here we have the Postgres read-write user. So let's say Postgres read-write user. For now, let's also set it to Postgres. Then I will change that. Right here on, we will change that. Postgres read-write password, and let's for now set it to the same password that we have up here. And so let's also come here. Let's copy this. Let's paste it right here. Okay, let's save this. So now we have copied the files. We have created our environment variables. So let's clear it once again so that we see it good. And now we can just say docker compose app, and it will start our containers. And we can see we have a small problem here, and this is because, as it says, our services.postgres.volumes contains an invalid type, and it should be an array. And so here it means that we just need to add a dash. Okay, let's then add it. Let's just once again push these changes. Let's pull them right here, and let's try to run it once again. And here we can basically see another error thrown by our application, and this time I think it has some issues connecting to our Postgres, and the reason is that here I think we have these commas, and these commas should not be here. That's not good, and this is something I forgot to remove. Okay, so once again, let's save that. Let's here on the left hand side clear our screen. Let's first stop the containers, and let's clear our screen. Okay, and then once again, let's make a comment here. Let's pull the newest changes in, and let's once again, let's say docker compose app, let's say dash build, so that the images are created once again. And this time I think we have a success. So what we can see here is that the database system is ready to accept connections, and that our application is started and listening on port 3000, and that we have successfully connected to the database. That's good. What we can check very easily is here. If we go to the IP address of our server, which in my case is the following, and then to the port, we should see our application running. And as you can see, it does not really show us anything yet, and it keeps loading and doesn't answer us. And here we can see an error that has been created inside the container, because now as we are in the interactive mode, we can see the logs from the container. The relation to-dos does not really exist, and that's correct. And this is a Postgres error because we did not yet create our database tables inside the database. Yeah, so that's good. So let's do it now. So to fix the problems, let's for now stop the containers. You can do that by pressing Ctrl+C, and it will attempt to stop the containers. Okay, and so now what we need to do is we need to make some changes to our Docker files, because we could just, because currently we need the script to be executed inside the container. And if you just want to get a list of currently running containers, you could just say docker container ps, and currently we will not get anything because we have stopped them. So we could just start the container bank again, and we copy the script to the container and execute it right there. But I think there is a better way to do that. And the better way is we will set up a volume in the container. So let's do it. We need to modify our Docker Compose file. So we are here in our Docker Compose file. Let's add additional volume to here. So let's say that scripts, and we'll create that for in a second, will be mapped to, let's say, /home/scripts inside the Postgres container. Okay, so now we need to create this folder here, scripts, and we need to put this file here so that we get it on the server later on. Okay, let's add it scripts, let's save it, let's sync the changes. And let's move to our server. So we're here, let's pull the newest changes. Okay, we have the newest changes here. And now what we can do is we can say docker compose app --build. And if you remember, let's just execute it. So it will create the containers, but it will create the containers in so-called interactive mode, meaning we will be saying the std out of these containers. So in other words, we will be seeing the logs like live, right? So if something happens, if they are initialized correctly and so on, right? So we can now see that, okay, the database has been started correctly, that our application has been started and so on. And this prevents us in this console from doing really anything else. And this is fine, as long as you don't want to just close your computer and go to sleep, because then it will stop the containers if I turned off the shell now. What you need to do actually, and let's press Ctrl+C. What you need to do is execute the same command, but add /d, so not slash, but dash detached flag, so -d. And this will start the containers as exactly the same, however, in a detached state. So you will not be seeing the logs from them. And now we can execute more commands. So now let's say docker container ps. This will just list all of our Docker containers. And we can see that now we have 2 running containers. Okay, and what we wanted to check is if we correctly set up the volume, which was supposed to map the scripts folder we have just created with the ddl.sql file to our database container. Okay, so let's do docker exec, and this allows us to execute a command inside a container, then -it for it to be interactive so that we can see the output of the command. And then let's say bash. This is the command we want to execute, and we get bash access to the container. Okay, let's inspect the home directory. And now we indeed have here in the home directory a scripts folder. So let's go into the scripts folder. And here we can see a ddl.sql file, and that's good. Okay, let's maybe move here once again. And now here we can do the exact same thing that we did in our localhost environment, which means we can use psql. So psql-u postgres -f, and now it was in the home/script/ddl.sql. And we see that we can get a notice because the table did not exist, because we specified the drop table if exists only. And now we can see that here we have the create table and we have the 3 inserts. So actually the 3 inserts some test data, which is maybe not what you want to do in a production environment. However, we can very easily remove these data afterwards. Okay, so that's fine. Let's currently exit out of our container. And now let's open our application, and now let's see if it works. So let's currently visit our application. So we go to our IP address, then a colon, and then 3000, which is the port. And let's see what we have, if we get anything. And indeed, it looks like our application is finally working. And currently, I don't know, you can ask your family members, you can ask your friends, they also will be able to access it here on this IP address and on this port. So let's maybe do a quick test. Let's try to delete something. Works. Let's try to add something. Yeah, works as well. Let's try to maybe remove something here. Let's maybe try to do something, and let's try to remove something from here. Yeah, well, works very well, actually. Let's save the site. Yeah, works very well. And so congratulations to you. At this point, you have deployed your application to a server. You have properly installed Docker and Docker Compose. We created the scripts together, and we did the deployment. So our application is working. However, there are a few final touches we can do. So let's do them. First thing we can actually do. So currently, if we want to deploy some changes, what we need to do is we apply the changes here in the codes or in the Docker files. We go to our server, we pull the changes, or we stop the containers, we pull the changes, and we start the containers back up. This is a lot of commands to execute, and what I like to do is I like to just create here a new file, call it run.sh. And now in this run.sh file, just say docker compose, just write here the bash scripts that you would normally. So docker compose down, then git pull, and then docker compose up --build -d to start it in a detached mode. What also makes sense to do is if you start a bash script to just add here hashtag and then exclamation mark bin bash, just so the system knows what it is. Okay, that's good. This is a very simple script that we can now use for the deployment. So let's test it. Let's go in here. Let's say let run.sh. Let's sync the changes. Let's go to our server. Let's wait for it to be synced. Okay, let's go. Now it's been synced. Let's go to our server. Let's actually let's do a git pull one more time, because of course we have to pull the script. Let's do an ls to check if we have it. Now we have it. And let's do bash run.sh. And we can see that it's stopping our containers, it's removing our networks, and it's pulling the newest changes, because here we can see that everything was up to date, and it has created the networks. Okay, so now let's test if our application still works. And here we have our application. Let's refresh. And it seems like it does. Let's try to maybe add a to-do. To-do has been added, so everything seems fine. Okay, so that's one thing that we did. So one more thing we should do from security perspective is we should create a user that has limited privileges that our application will use to connect to the database. So let's say now currently Docker container ps to once again generate a list of running Docker containers. Let's grab the name here, and let's say docker exec-it, the name of our container, and then let's say bash. This way we will access the container. Let's log into our database, and now let's say create user. Let's call it app_rw for read write, and let's say with password. And let's generate it the same way we did it last time. So here we require crypto and then random bytes, and then we change it to a hexadecimal string. Let's copy this one. Let's go back to our console. Let's place it inside single quotation marks. Okay, so we have successfully created the role. Now what we need to do is we need to grant privileges to this role. So let's say grant, and we want to grant select, insert, update, and delete on to-dos to app_rw. And that's it. We have granted the privileges to our user. Let's now quickly check if it works. So what we can do is we can exit here, and in bash let's try to do psql -u, and now not Postgres but app_rw. Currently we need to also set the database you want to use, so we say psql -u app.rw-d, and database is called Postgres. No, and I made a typo, app_rw. And currently we are connected. Good. Okay, that's good. Let's just check maybe if we are connected using the correct user. If I remember correctly, we can just say select user, and we can see that the user is in fact app_read_write. Okay, so that's good. Let's disconnect and let's exit bash here. Let's exit our container. We need to do one more thing. So let's currently go inside our folder here and let's open our .env file. And inside the .env file, we need to replace the password here, and we need to replace the user here, RW. Okay, and currently what we can do is we can once again run our script to recreate the containers. Okay, that's good. So here they were started good. We can now check if our application still works. And it looks like our application doesn't work. Okay, so let's check out what's going on. And currently what we can do is, if you ever want to get the logs from the container, right, because of debugging purposes, you can just take the name of the container, and this time we want to take the app and just say docker logs, logs, and then the name, and here you have the logs. And what you can see here, our database does not exist. So after some digging, what I think, where I think that the problem lies is currently we are using a wrong. We are currently using a wrong macro variable to set the names here, because here, if you take a look, we are using the Postgres database, and I'm pretty sure that for the actual Postgres image, we should be using Postgres_db. So let's also set here it to Postgres.db. Let's go to here and also change it to db. Okay, that's good. Let's actually var name. Let's sync it. Let's bring the newest version after it's synced to our server. Okay, let's do bash run.sh. Okay, that's clear. And now we can check if everything works. Let's go here, and now we can see that our application works. Let's try if we can do a to-do. Looks like we can. If we can remove from here, let's add a new to-do. Okay, that's good. This means that the deployment works. From security perspective, I believe what's also important is that if you remember correctly, we have configured an uncomplicated firewall in the previous episode. And currently, what we are doing is exactly we are connecting to the server on port 3000, and this is what we were not supposed to do. And this is a security concern that you should be aware of when you are using Docker Compose. So the moment we have mapped the port inside the container to our port that is on the server, there was also an opening created on this port so that we are able to connect it to the outside world. So this is a security concern that you should know. Now, one more thing that we could do is here, if you remember, we exposed or we mapped the ports of the container here in the Docker Compose. This is actually not necessary. This is only necessary if you want to access this database from outside, so not as we do using the Docker Exec, but if you wanted to, for example, connect from your local machine directly to the database, this would be necessary. I believe currently, as it's not, we can just disable it for security purposes. So we can once again go back here, and we can just once again execute. This is why, now you probably understand why this run.sh file is so useful, because you can very quickly apply changes. Okay, let's now check if our application works. Okay, let's check if our application is now working. Let's maybe add a new to do 3, new to do 4. Let's try to remove it. Let's try to do it. Let's try to remove it from here. Okay, fantastic. This looks like it's working. So in today's episode, we've done a lot. We have installed Docker, we have prepared the Docker files, and we have prepared all the configuration that we need for it. We have deployed our application, and we have actually applied several security checks to our application. That's, I think, a lot of work, and that's well done. I'd like to thank you for today, and we'll see each other in the next episodes.